Greetings and welcome to my second part of the Astar tutorial, Astar pathfinding tutorial for Godot. My name is Clint Fleetwood, and like I said, this is a second part of a two-part series on the Astar pathfinding. This one, unlike the first one, is actually in a 2D space instead of a 3D space, and it is using my custom-built Hex module. So if you haven't seen the first one, I would recommend going to look at it. Because I'm going to gloss over several things that are important in that one and show you how to use this with like external tools such as my Hex module. Before I get started, I really want to take a moment to thank Juan and Ariel. I'm not certain if that's how you pronounce your name. If it is incorrect, just I apologize. They're the creators, or the original creators of Godot. There's several community help. There's a lot of people writing code for it and helping and doing a lot of stuff. But I just want to publicly thank them too, because the Godot is wonderful. They were not required to share it, and they did, and it is great for the community. And the community as a whole for Godot is one of the best online communities I've been a part of, as far as based around a game engine or a project like this. So I just want to say thank you to everyone. I want to say thank you to all the people that have been watching my tutorials and giving me encouragement. And I'm really excited to be putting out more and moving forward. This is going to be around Godot 2.2. There's some really exciting stuff with 2.2, but I'm extraordinarily excited about the potential of Godot 3.0. And where it's going to take Godot in the future. So a lot of really good things coming around with Godot. It's a great time to get started, and if you're going to work on a project right now, is a really good time to get started and kind of learning some things and some really cool stuff with it. Alright, without any further ado, let me give you a couple caveats like I always have. One of the things that you have to make sure you have is, for this to work, and it may not even load, for this particular one, you need my Hex module right here, and you can get that. I'll put that link into the folder. You would actually need to compile it from source by putting that in the modules folder, and telling you how to do that on the Godot's documentation is pretty clearly documented. It's pretty easy to do if you know how to do that. I did give one caveat. The name, you'll actually right here it says I named it Hex, so the folder name needs to be Hex instead of capital Hex module, and you'll see that. If you have any questions, definitely shoot me an email or give me a message in the document. In the video. Anyway, so let me show you how this works. So just go ahead and play it. And as you can see, this is just a grid, and I've also kind of made it more like where you could use this and you can download it and test around and play with it and see how it works. You can change the grid type from pointy to flat and back and forth, because that's part of the Hex module. You can actually add obstacles by left clicking, and the black means it's completely not passable. You can remove that by left clicking. You can add and remove obstacles by left clicking, and then you can also change the starting location by right clicking. It changes where it starts, so you can basically build a little thing where you have to go around like that. Also, you can change the weight value of each one of these areas by moving this slider and then middle mouse clicking. And so the light blue is supposed to represent kind of like shallow water. The dark blue is supposed to be like represent, I don't know, just deep water, and then the brown is supposed to represent brown like grass, dirt instead of grass, so it takes a little longer to get by. So as you can see, these weights affect how much the travel cost is, and that's one of the important things, is knowing that if you're trying to travel, see how it's kind of looping around, then goes up, because it's calculating the travel cost to get from that location to the next location or whatever. So this is pretty, see how it tries to go through just that one instead of going through, which would be the shorter path, instead of coming straight through like that. It does different things. That's basically how this works. That's adding weights as we go. So that's just the overview of what it does. Let me kind of guide you through how I built this. and then you guys can look at it and do whatever you want to with it. On the 2D stuff, it's pretty self-explanatory. I just have a grid type for the slider, and it's actually 1 or 0, or 0 or 1. That's the grid type. I got the weight points, and then the panel, and then the travel cost is this little text right here. So that's, again, not very complex, pretty simple, self-explanatory. There's all kinds of tutorials about Godot that help you with that, and that's just in instructions. All right, over here, what we have is I have the different drawers, and I don't know if this was the best way to do it or not, but each one of these is a Node 2D, and if you are looking up Godot and you look up Node 2D, you have, a canvas item, which is a child Node 2D. You actually have the draw function. That's a virtual function that you can override. And so what I did for each one of these items, I have a little script beside them to draw the different things that we're drawing. I'm not going to go into too much detail to this, but this is unlike 3D where I was getting an instance mesh and then use that to draw. This is actually using just straight up the 2D draw techniques, and I'm not going to go over that, but basically whenever you see something drawing, that's what it's doing when it calls that draw function. So going right here, this the Hex module works pretty good. I'm pretty happy with it, and I'm going to show a couple things that are a little different than what I was using before. If you looked at the other one, you saw the make grid function on my square. That's actually making the grid from nothing. Actually, that's the wrong. Sorry, that was the wrong. That was last week's. Anyway, so this is this week's make grid. We're using the hex grid. The grid is actually already made by using the hex grid get map. The get map is actually, if you use the module, you can actually see all the functions that come with it. So as you can see, get map just returns, and I don't know how to add what it does. I guess I need to look that up. But get map actually just gets the map that's just an array of the different items. So unlike on the world where we had to basically completely make the grid, this one we're doing the make grid. We're actually just basically making a dictionary from the hex grid map, and that makes it where we can actually add, is it an obstacle, how much does it travel, weight, cost, what is the ID, and the name of the hex. So that's what we have going on right there. So let's go ahead and just jump right in. The ready. Set input process to true. That's what this function's called. Not a big deal. And these are the functions that are required for the hex grid module. You need to set the size, or it's going to default to 1, I think. And you need to set the rows and the columns. All right, and then you set the layout. And then once you set the layout, it actually makes the grid available for you to use using the get map function. And that's really all you got to do as far as my engine my module goes, my hex grid. That's all you've got to do. Oh yeah, up here, forgot to say, you got just like you did before, the Astar new and then hex grid new. To get that hex grid new will not be in it unless it's compiled from source, of course, because that's mine. All right, and then you simply just go to make grid. All right, so what I did was I went ahead and disconnected all the points, which is not really, it's right here. It just disconnects all the points that we have, and just like before, instead of actually having to like you make the neighbors like I did in the world, the hex grid actually has a function, hex neighbors, and so then it can go through and disconnect all the neighbors. So if it's in the hex map and the points are connected, disconnect those points. Really simple. And disconnecting points is what causes the grid to become or the grid item to become a obstacle. And then this empties out the obstacles. I did it like this because I can call make grid from different times because I changed from pointy to flat. So I basically re-clear it all and then before I get started. And then I go ahead and make the grid, and then I connect all the points. And you can see right here, down here where it says connect points, for every hex in the hex map connects the points. Alright. And then the last thing it does is it adds an Astar point, which is a function right here, which I guess I could have just done, just copied that up there, but I decided to do this this way because, because this is called from elsewhere. And so the Astar, this is using the Astar function options, add points, and then Astar ID, which is set right here because it's just sequential because it has to be an integer. And then the hex is the hex. Now, this is kind of like breaking it a little bit, I think, and maybe this may be one of the reasons why I'm having a small problem with the weights being wrong, and I'll show that in just a second. But the hex is actually a vector 3, even though it's not a vector 3 location. It is that may be a little confusing, but it really is just 3 points, which QRS, and I just went ahead and used the vector 3 for my hex module because it was there and it was easy. So that hex is QRS, not an actual like location, like this grid. This grid represents locations. With the hex module, it doesn't. That may be causing a small problem that I'm having. I don't know for sure, but it seems to work. And then it adds the travel weight. Now this is what's different than last time. In the other one, we didn't have weight, and so everything was basically 1. Well, now the weights are based on this property in this dictionary, and so it grabs that and then adds that weight there. Now that weight is a modifier that changes how many, I guess, points it costs to go between the different items. Alright, and that's, other than that, it's basically the same as the world on the first one, not using the hex module. But the weights actually make a big difference in where the path goes, as you saw before. So that's the only difference, is just setting the weights right there. I do have it where you can connect and unconnect points, and that's important because one thing that you have to be careful about is we have to make sure when you're connecting points that the point it's connecting to is not an obstacle, because if it is and you try to connect it, it'll make it where you can actually go through it. So that's a little caveat. If you're putting something next to something else, you need to make sure that it's not connecting to an obstacle and creating a point, a one-way point. And that's what I'm doing, checking right there. So whenever I left click, it actually runs that. It disconnects all the points, and then when I left click again, it actually reconnects the points. But we don't want it to reconnect to that one or this one or this one, because if it did, that means it would make it where it's no longer, it can go through it, and we don't want that to be the case with obstacles. And that's really all that I have that is different. Again, if this is a little confusing, you should be able to look at the first tutorial, and it gives you a better overview of all that's done. Maybe here's a little different where I used inputs. This is just checks to see if it's button 1, button 2, or button 3, or if it's moved, and that's how it's connecting to it. And it's actually looking for the position, and then uses the hex grid to determine, because the hex grid can get from point to hex. Oh yeah, that's one last thing I forgot to mention. This offset, since it's on 2D, I had to offset the node, and I'll show you right here. See the drawings offset? They're offset by like 32, and so what that means is when they're drawn, they would actually start right here, and so the mouse would actually give you the wrong hex click if we didn't use get that offset. And the offset's pretty easy. It just gets the position of the drawing grid, which right here is 32, 32. So it just subtracts that and gives us the right position for the mouse. If you're doing it where you can scroll the camera over a long area, that's something you have to take into account, like the initial position versus the what's on the screen, and that is something that you would need to look into, because, and actually right now, since the screen doesn't move at all, I only have this one offset, but you would actually need like a view offset as well, to say you moved over like two camera panes worth. You would need to know that, or this would return the wrong hex back on all of these. So and then just look over these to see how you do the different drawings. That's really kind of it. This one's a little shorter, and I just wanted to go over it really quick and show you how to use that. Oh, I did have one. Okay, yeah, the one last thing I forgot about is sometimes, and this may be because of the way I do. I've done my hexes, but let's say I go right here. That cost value is 9. Actually, that one's right. Let's see here. Because of the way I use hexes as a vector 3s instead of it actually being actual locations. So we can see right here it's 9, right there it's 7, and right there 7.5. Those numbers don't really add up all the time, and so it's like the travel value maybe a little different than what I was expecting. And I'm trying to get an example. Okay, so right here it's 17 because it goes all the way around. Right here is 7. Well, cutting one across should only be 1.5 more. And I don't know if that's a bug on my end or if that is my calculating is wrong. I would really need to hear some feedback from somebody to see exactly why it does that, because this really should be, if I move right there, going through that one time would only take travel cost of much less than that. Now if I did this with these, it probably will go through right there, see, and that gives a more accurate picture of what. And then until I go down here, it doesn't try to. Still, it goes around a little bit more. I don't know if that's because my calculating travel cost is not accurate to what's actually going on, or whatever. But that's something I've trying to figure out, and I would like to know if you have any thoughts on that. Anyway, but again, Astar is still very new, so that may be something that's looking into, or maybe a problem on my end. Either way, it looks like it does give good results, but it doesn't necessarily give the best results. And I don't, or it might be giving the best results, and I might just be calculating or adding incorrectly. So again, I'd love to have some feedback on this one. This one's a little bit shorter, and I just wanted to share it with you.